Welcome to two more examples on how to simplify an expression with a negative rational exponent. We're asked to simplify each expression over the real numbers. So first we're given negative 8 raised to the power of negative 4/3. So for our first step, we'll write this using a positive exponent. We're looking at our notes below. A raised to the power of negative m equals 1 over a raised to the power of positive m. So we can think of the left side as a fraction with a denominator of 1. So if we move this down to the denominator, the sign of the exponent changes. So looking at the given expression, in fraction form we have a denominator of 1. So if we move this down to the denominator, the exponent will change to positive 4/3. So this is equal to 1 divided by negative 8 raised to the power of positive 4/3. And now to simplify here, we'll write this in radical form, or again referring back to our notes, a raised to the power of m divided by n equals the nth root of a to the m, which we can also write as the nth root of a raised to the power of m, where the exponent is outside the radical. So notice how the denominator of the rational exponent tells us the index, and the numerator of the rational exponent tells us the exponent. So notice how for our example, the rational exponent has a denominator of 3, so we have a cube root, and the numerator is 4, so we have an exponent of 4. So in radical form, we would have 1 divided by, again, we're going to have the cube root. The radicand is negative 8. Notice how because the negative is inside the parentheses, it goes inside the radical. And then because the numerator of the exponent is 4, all this is raised to the 4th. And let's put the exponent outside the radical. Now we want to simplify the cube root of negative 8, which means we want to determine if negative 8 has any perfect cube factors. And negative 8 is actually a perfect cube because negative 2 times negative 2 times negative 2 equals negative 8. Or if we want, negative 2 cubed equals negative 8. So we can rewrite this as 1 divided by the cube root. Let's go and just write negative 8 as negative 2 cubed. And all this is raised to the 4th power. Well, the cube root of negative 2 cubed is going to simplify perfectly to 1 factor of negative 2, but this is still raised to the 4th. And negative 2 to the 4th is going to be equal to positive 16, so this simplifies to 1/16. Now let's take a look at our second example. Here we have negative 81 raised to the power of negative 3/4. So in fraction form we have a denominator of 1, and therefore if we move this down to the denominator, the sign of the exponent will change. So we can write this as 1 over negative 81 raised to the power of positive 3/4. Notice here the denominator of the rational exponent is 4, so we're going to have a 4th root, and the numerator is 3, so the exponent is 3. So in radical form, we'd have 1 over, we're going to have the 4th root of negative 81. Again, the negative is inside the radical because the negative is inside the parentheses here, and all this is raised to the 3rd power. Now we want to simplify the 4th root of negative 81, which means we want to determine if there's a number raised to the 4th power that would be equal to negative 81. In this case, there's not, because notice how if we tried negative 4 times negative 4 times negative 4 times negative 4, if we wanted negative 4 to the 4th, that would be equal to positive 81, not negative 81. And of course, if we tried positive 4 times positive 4 times positive 4 times positive 4, or 4 to the 4th, that's also equal to positive 81. So because there's no real number raised to the 4th power equal to negative 81, we could stop here and say the result is not real. Well, we could simplify this over the complex numbers because the directions say simplify over the real numbers. We just stop here and indicate the expression is not real. In our homework system, I believe we're supposed to enter D and E for not real. I hope you found this helpful.